Example 5, roller coasters. Suppose the 320 kilogram roller coaster below is at rest. I'd probably mentally underline the word at rest. At the top of the first hill, it's given a very gentle push, like bing, just barely. It's almost ready to fall and starts to roll. So even though technically it starts off bing with a velocity that isn't quite zero, let's just say VI is 0. Okay. How fast will it be going at location A? So if you know how high the roller coaster hill is, you have a pretty good idea of how fast you'll be going at the bottom of the hill. Braden, what's this question asking me to find? Okay. Does it say find the velocity? Did it use the V word? No, and I did that on purpose. You'll either hear me ask for a speed or how fast, and that's my hint to you, Sarah, to say you want to probably use a scalar approach. I'm not going to ask you to find the velocity. Braden, if you look at this, is there a change in the height?
Yeah.
Is there a change in speed?
Yes.
Is there a yucky, curvy path?
Yeah.
That's a job for conservation of energy. So the conservation of energy equation says this. KE initial plus PE initial equals KE final plus PE final. And there's no indication in this question that they want me to include friction and heat, so I'll leave it off. Are any of these zeros? Well, let's look at kinetic energy. Are we ever at rest? Oh, initial? Let's look at potential energy. That's MGH. Are we ever on the ground? Where? You mean PEI gets to stick around for a change? Okay. And I'm going to get this. MGH initial equals a half MV final squared. Braden, have you gone on a roller coaster before?
Yeah.
Do you like roller coasters?
Oh, yeah.
Before you went on the roller coaster, did they make you step on a bathroom scale? Did they have to measure your mass? No? Did they have to spread out heavy people and light people?
Yeah. No.
No? I don't think they did.
Yeah.
You know why? What? Turns out, now I'm fibbing a little bit. If we include friction, the M's don't cancel, but are roller coasters really well greased? Yes. Is there much friction? No. So in my made-up perfect physics world example, the M's cancel. In real life, the mass is negligible. An empty car can go through the roller coaster just as easily as a full car or a half-full car. Braden, what were we trying to find?
How fast that location?
Oh, V. I think times by 2. That gives me VF squared equals 2GHI. Braden, how do you get rid of a squared?
Squared.
Okay. If I'm trying to do this in my head while I'm standing in line, for G I use 10, but I estimate the height, or you can actually figure it out with trig, and there's even some apps that'll do it. Or I'll ask and do some research. Oh, I know how high the first hill is. So times by 10 times by 2, square root of that, that's about how fast I'll be going. Honestly, it does add to standing in line, I think. So it's going to be square root of 2 times 9.8 times 90 . I get 42 meters per second. Is that a good ride? Is 42 meters per second fast? Somebody times that by 3.6. How fast is that? How many kilometers per hour? Oh, that's a good, I'm going on that. Yeah, that's good. I'll take that. 42 kilometers per hour. Meh. 42 meters per second. Yeah. How fast will it be going at location B? I got several options. Look up, but don't write this down. For part B, I could let this be initial and this be final. Now, why might I do that? Well, that cancels out one of my MGHs because I'm starting on the ground somewhere. Why might I not want to do that? Well, if I go this as initial, I'd be using this answer to find that answer. I might make a silly mistake. So I'll show you an actual better way to do this. Are you ready? Put a little I right there for initial. Put a little F right there for final. But because work and energy is a scalar, mathematically, Sarah, I can put the ground wherever I want. What I'd like you to do is draw a dotted line for the ground that's right at the same height as location B. I'm going to pretend that B is on the ground. Now, why would I do that, Calvin? Calvin, what does B want me to find? Is there a change in height? Is there a change in speed? Is there a yucky curvy path? Conservation of energy, GG. So I'm going to set it up the same way as I did before. KE initial plus PE initial equals KE final plus PE final. Are we still starting at rest? That's kind of why I went with that one, because that cancels. And I'm going to pretend that that's the ground. So I'm going to argue that that's my final potential energy is 0. But here's the question then. What's the actual height? Not 90 and not 50. 40. Yeah. That's the beauty of work and energy, is you can put your 0 point wherever you want to and just adjust your heights accordingly. So I'm going to get, in fact, the same equation as before. Braden, I'm not even going to bother rederiving it. I'm going to go VF is going to be the square root of 2GH initial. It's going to be the square root of 2 times 9.8 times 40. Oh, no squared, Mr. Duke. Square root of that. You could, by the way, do your initial height of 90, and the PEI would be 2 times 9.8 times 90 minus your final kinetic. You could do all that, but ugh. Second hill, 28. Still pretty good. Around 80 kilometers per hour. Is it 100? Okay. Okay. There's a third hill. Not shown. The roller coaster has a speed of 12 meters per second. How high is the third hill? Whew. Alex, what's this question asking me to find? Height. Is there a change in height? Is there a change in speed? Is there a yucky curvy path? Okay. Conservation of energy. KE initial plus PE initial equals KE final plus PE final. Where is initial going to be? You could either put it here or here or here. I think I'm going to use here because at least KE is 0. I could use here. I'd be using my answer from part A for the kinetic energy, and their MGH initial would be 0. Don't think I'd go here because nothing's 0 there. So let's use our initial as right here. So are any of these 0? Well, we are starting at rest. Are we ever ending up on the ground? Are we starting on the ground? And we're at the top of the third hill, so is that on the ground? No. We could, and what we'd actually be finding is the change in height. Good day, my angel. Pause for a second. So, Sarah, we could. And if you do that, go right ahead. I'm going to not do that this first time, and maybe another time we'll do the shorter method. For now, I'm going to say, okay, it's going to be, oh, what is potential energy? What's the equation for gravitational potential energy? So it's going to be mgh initial, and kinetic is a half mv final squared plus mgh final. Alex, do you like roller coasters? Yeah? Yeah?
Yeah.
Before you got on the roller coaster, did they make you stand on a scale? They'd have to spread everybody out? Why? Okay. M and everything. That's convenient. How would I get the H final by itself? Well, it's on the right-hand side, so I guess the left-hand side is going to drop down like a domino. This first term is 0.5 v squared. What's the... Oh, I erased the f accidentally. This first term is 0.5 v squared. What's the 0.5 v squared doing to the H final? Multiplying? So how will I move it over? In my mind, don't write this next bit down. In my mind, I imagine the GH final dropping down like a domino. How would I get the H final by itself? AJ, how do I move the G over? What's the G doing to the H final? So I'll divide. There's an equation. Not too bad. The final height, top of the third hill, is going to be 9.8. What was the original hill? 90? Times 90 minus 0.5 times 12 squared all over 9.8. (9.8) times 90 minus 0.5 times 12 squared divided by 9.8. Any typos? I don't think so. Am I expecting a positive or a negative answer here? Should get a positive, I think. Yeah. You get 82.6. Okay. Which makes sense because 12, remember at the bottom of that first hill, it was going 42 meters per second. At the top of hill 3, it's going only 12. It's lost most of its kinetic energy. It must have picked most of its original height back up. Is that right? Is 82.7? I said 82.6. 82.7? Yeah? Example 5. A roller coaster car travels as shown below. At point A, it is moving at 12 meters per second. How fast will it be moving when it reaches point B? So now this isn't the first hill. Maybe this is the second or third hill. We've got some speed. How fast are we going to be going at the very, very bottom? Cool. We can handle this. Kieran, what's this question asking me to find? I got to be fussy. No. No. Give me a word that starts with the letter S. We're in Scalarville. We can't find the velocity. We can find a speed, though. And conveniently, the speed is going to be in the direction that I want, so I'm good with that. Okay? Is there a change in height? Is there a change in speed? Is there a yucky, curvy path? Conservation of energy. Are any of these zeros? Kinetic energy initial is 0? What's our initial speed? So is our initial kinetic 0? No. Okay, are any of these 0? That's the only one. Okay. I'm going to get a half m v initial squared plus m g h initial equals a half m v final squared. Kieran, do you like roller coasters? Been on one before? Before you got on, did you step on a bathroom scale? Did they have to spread out all the heavy and light people? Why not? What are you trying to find, Kieran? Okay, I'm going to show you a good trick. Okay, what's in front of the VF squared fraction? Okay, a fraction. I'm going to clear the fractions out because there's also a 1/2 here. I'm going to go like this. I'm going to multiply the first term by 2, the second term by 2, and the third term by 2. It's an old trick for clearing out fractions. And I do that often, Alex, if I see the same fraction appearing numerous times. Because, Kieran, what's 2 times a half? What's half of 2? What's 2 times a half, folks? Yeah, and in fact, that cancels, that cancels. I am going to end up with a 2 here, but I'd rather deal with 1 2 than 2.5s, 2 halves. And I get this. VI squared plus 2 GHI equals VF squared. Those of you who are paying attention might say, Mr. Dueck, don't write this next bit down. That looks an awful like VI squared plus 2AD equals VF squared, doesn't it? And that's actually another way to derive VF squared equals VI squared plus 2AD. That equation that I stuck in the kinematics section, technically it's a scalar equation out of conservation of energy, which is another reason why sometimes when you used this equation, especially when you square rooted, you had to add the direction in yourself. You had to add the negative in afterwards because this is technically a scalar equation. That's pure #nerd trivia. What am I trying to find? Oh, I've got it by itself. Or do I? Oh, square root. There you go. So it's going to be the square root of 12 squared plus 2 times 9.8 times 18. I get, square root of that. I was going to say 496 point, that's a fast roller coaster. That's faster than sound. Do you get 22.3? The first couple of examples worked out evenly. Don't expect that. It's really tough to make these work out evenly. Is this a good coaster? Times by 3.6. 80, okay. Yeah, I'd go on that. Especially because it's the second hill, so probably the first hill was better. Right? All right, suppose you bring a radar gun with you. I have a radar gun that we bring with to Playland. And you realize that the coaster is only traveling at 15 meters per second, not at 22.3. How much energy was lost to heat? Ooh. Well, is there a change in height? Is there a change in speed? Is there a yucky curvy path? I'm going to use conservation of energy, but I'm going to add one more term to the equation. I'm going to go kinetic initial plus potential initial equals kinetic final plus potential final plus heat. That's one if you want to add to your purple sheet, you can, but I'm not going to let you add that to your yellow sheet. I'm going to expect you to be able to reason, he's talking about the work done by friction or heat that goes on the end there. Are any of these 0? Well, we're still ending up on the ground. But I don't think anything else is 0. They want me to find the heat. Okay. How would I get the heat by itself here? How will I move the KE final over? Subtracted. Sarah, this is a weird one. I like this question. I like this question. I like this question. For some reason, when kids get in this equation, heat by itself, they often divide by KE final, or they divide by PE final if that's not zero. And I haven't figured out why, because there's plus signs like everywhere. But I'm just saying, be cautious with this. So I'm going to get this. A half mv initial squared plus mgh initial minus a half mv final squared. That's what Sarah said. That equals the heat. Do the m's cancel this time? Why not? Isn't there an m in everything? No m in heat. And that's why in real life, Sarah, your mass does make a difference. But as long as we grease the coaster down and keep the heat to a minimum, you may have seen an empty coaster will go through the roller coaster just fine, as well as a packed roller coaster. So the mass is negligible. Heat equals a half, what was the mass, Mr. Dewick? 245. 12 squared plus 245 times 9.8. Yeah. Because what am I trying to get by itself? Heat. It doesn't have a fraction in front of it to get rid of? Great question. The other one did, so. And that I also, if you ask me, why did I really do that? I wanted to show you that this is VF squared equals VI squared plus 2AD in disguise. Because nerd trivia. What was the initial height? 18? And then I have minus 0.5 times 245 times 15 squared. And so, yeah, I don't need to do anything fancy here. It's just going to be straight plug and chug. No square roots or anything like that. A half mv squared plus 245 times 9.8 times 18 minus a half 245 times 15 squared. And I get 33295.5. Anybody else? I'll call it 33,300 joules of heat. What's your homework? Number one. Take a look at number one for a second, please. We're going to do part of it together. First of all, number one, part one, what's the potential energy of that young skateboarder if they're on the ground? What's their kinetic energy? Do they have a speed? Can someone on your calculator go a half mv squared real quick for me? $240, is that right? Anybody else? Yeah. No, yes? Yeah. What was the potential energy? I'm seeing people squint. I got to double check that. How about 1,920? Okay. How much potential energy did they have? What's their kinetic energy? What's their total energy, their mechanical energy? Add them up in your head. This is the number that's not going to change. You're going to have 1920 joules here. You're going to have 1920 joules there. What is changing is your height or your speed. Well, okay, at the top, what's the speed of this person at the top for a split second? So what's their kinetic energy? So what's their potential energy? And you can use MGH to figure out their height. In the middle, you can use MGH to figure out how much potential energy, whatever's left, must be kinetic, and then figure out the speed. Okay, so that's number one. 2, very similar, roller coaster. 3, very similar. 4 is good. 5 is good. Probably going to assign most of this. Yep. 6 is good. 7 is good. Take a look at 7, part 1. What's the initial speed of that car? And what's its energy? 10 to the 6th. What's the speed of the second car? Twice as fast. What's your new energy? What's the speed of the third car? 90? 3 times as fast. What's your new energy? Your hint is it has something to do with a squared. Okay? It's 9:40. I'm going to give you till about 10 a.m.-ish to work on this, but then we need to do lesson 6.